So our next section is about annuities, future values and sinking funds. So let's define annuity first. A sequence of equal payments made at equal period of time is called annuity. So remember how we discussed about simple interest and compound interest. So in that, what was happening? We had a fixed deposit or a loan, right? We were keeping that in the bank for a fixed period of time, and that at the end we were getting future values. So this is called our present value. We had a time. In the compound interest, compounding was being done over a period of times, and at the end we got future value, and bank gave us our percent of the interest. But usually people don't save a big chunk of money. They would be saving a small amount of money every month, suppose, right? Every salary check. So annuity is like equal amount of payment. Say I have one payment I make today and I keep it for say 5 years, and then next year I save a little more money, I put that in the same account, then the next year I make another payment. So same amount of payment I'm saving every year and I'm keep putting it in the account, and at the end I will get a big chunk of money which will be my future value. And on all that, bank gives interest, right? And most of the times that is compound. The interest is compound interest. So this is called annuity, when instead of one fixed deposit you are making small payments over equal intervals of the time. So the time between the payments is called the payment period. Time from beginning of the first period, first payment, to the end of the last payment is called the term of annuity. So time between is called the payment period, and the time from starting to the end is called the term of annuity. Annuities can be used to accumulate funds. For example, when you make a regular deposit into a saving account to save a large chunk of money, say we are collecting a down payment for a house, right? We will keep saving our small savings from every paycheck, and we try to get that to a big down payment, something like that, for in a saving account. Or they can be used to pay out funds, as when you receive regular payments from a pension plan after you retire. Sometimes company, when they hire you and they have a pension plan, what they do is they put a big amount of money in your account, in your pension account, and after you retire you keep getting payments at every month's end, right? So you are getting regular payments out of that payment pension fund. In this section, we are discussing annuities in which the funds are accumulated by regular payments. Regular meaning all the payments are equal into an account or investment that earns compound interest. So we are talking about the annuities which have compound interest. The future value of such annuity is the final sum of the deposit. That means when the whole term of annuity is finished, how much money is deposited into the account will be the future value. That is total amount of deposits and all the interest. So how will that be calculated? Every payment plus all the interest on those payments. Now, ordinary annuity, what is that? These annuities where the payments are made at the end of each period. So payment is made at the end of each period, and the frequency of the payment is the same as the frequency of compounding interest. So if it is payment is done monthly, compounding is also done monthly. If the payment is done semi-annually, compounding is done also semi-annually. So these are ordinary annuities. So in our curriculum, we are going to only talk about ordinary annuities. Okay, so remember, in our annuities, the payment will always be regular and the frequency of the payments will be same and the same as the compounding of the interest. This is important. Our curriculum only take ordinary annuity. So you need to remember few things, that what is the payment period, how much is the payment, how much is the term of payment, what is the future value. Okay. So let's do an example and understand. This example is going to show you what we are saying about annuity. So here let's read example 1. They say the saving accounts 1500 is deposited at the end of each year for next 6 years, in the saving account that pays interest of 8% interest compounded annually. Find the future value of this annuity. So let's see what's happening. So we have 6 years, right? At the end of each year, so first year, second year, third year, fourth year, fifth year, sixth year. At the end of each year, they are making a payment of 1500. Second year's end, 1500, 1500, 1500, 1500 and 1500, right? 1500 is deposited at the end of each year for next 6 years in an account which pays the interest rate at 8%, that is 0.08, and which is compounded annually. Okay, you have to remember that. Find the future value of annuity. So this is what you see. This $1500 is deposited at the end of each year for 6 years. Let's look at each of them separately. The first one, how long does that money keep into your account? We put it at the end of the first year. So 1, 2, 3, 4, 5. It stays in the bank for 5 years. So at the end of 5 years, how much will be that amount because of the compounding interest, right? Compounding annually. So remember the compounding formula, that will be 1500 times 1 plus 0.08 because of the interest divided by 1 raised to power 5 times 1 because compounding annually, right? So that will be the amount. So I can just say this will be equal to 1500 times 1.08 raised to the power 5. So the amount which was in the first year, at the end of the first year. What about this second year? This amount keeps in the bank for how many years? 1, 2, 3, 4 years. So at the end of these 4 years, that amount will become 1500 times 1.08 raised to the power 4 on the same terms, right? Which amount is at the end of third year will become 1500 times 1.08 raised to power 3 because that stays in the bank for 3 years. This one 1500 times 1.08 raised to power 2. This one 1500 times 1.08 because that is only 1 year. Now this last payment we just deposited in the bank at the end of the 6 years. So that is just 1500. There is no interest on top of it. So we started at the first year, at the end of first year we deposited 1500. That earned interest, compound interest at 8% and became this amount. Then we deposited another 1500 in the same account. At the end of those years, that stayed in the bank for 4 years and became this amount, and so on. So what is the amount total final future value in the account will be what? That will be the sum of all these terms. So we can say 1500 plus 1500 times 1.08 plus 1500 times 1.08 square plus 1500 and so on add until 1500 times 1.08 raised to power 5. So we are adding basically all these terms starting from here. We are adding all of these to get our future value, right? So if you calculate that all, that is 1500 times 1 plus 1.08 plus 1.08 square plus 1.08 cube plus 1.08 power 4 plus 1.08 power 5. Sum of all that is coming to be equal to, that would be equal to 11,003 times 0.89 cents. So that will be the amount in the future value. Now we don't always have to go through this. This was just to make you understand how the annuity is working. So we can remember this formula here. So here is the formula for you. The future value of an annuity, how do you calculate? So first of all, understand the terminology. FV is the symbol for future value here. PMT is the payment at the end of. How much was the payment? The last question we were paying how much? 1500 at the each period. I is equal to R by M. R is the interest rate given by M. So how many, what is M? M is the number of periods per year, meaning I is the interest rate per period here. R is the annual interest rate. N is the total number of periods. So basically N will be equal to M times T, right? M, how many periods in every year, times how many total years you are keeping the money in the account. So this is the formula. So let's use the formula for the given problem what we had. Future value is equal to, payment is 1500, 1 plus I is R by M, so 0.08 by 1 raised to the power, total compounding periods were 6 minus 1 divided by 0.08 by 1 basically, right? So you can calculate that. Let's try it and see if we get the same number. 0.08 raised to the power 6 minus 1 divided by 0.08 times 1500. So you get exactly the same amount, 11,003.89. So you can also use this formula for calculating your future value of the ordinary annuity, but you need to understand what your terms are, okay? Now we can also use the calculator for this. So I want to show you the TVM solver.